to talk about decimal and binary and talk about the difference between them. Well, what are these decimals and binary in general? When human being wanted to count, they found the numbers of 1, 2, 3, 4, and then after when we were getting to the bigger numbers like 10, 11, 12, they needed a system to be able to remember um, um, the the numbers and also to be able to remember how the digits look like. So they invented different systems for numbers, and each system was based on a different number. For example, the system that was based on 10, it was called decimal, and the system that was based on 2 is called binary. Now, what do I mean by based on 10? It means that in a decimal system, for example, we have different boxes, and each box is 10 times bigger than its adjacent box. For example, this box is 10 times bigger than the first box. The third box is also 10 times bigger than the second box, but it makes it to be 100 times bigger than the first one. The fourth one is 1,000 times bigger, and the fifth one is 10,000 times bigger, right? Or in other words, 10,000 is 10 to 4, 1,000 is 10 to 3, 100 is 10 to 2, 10 is 10 to 1, and the first one, 10 to 0, we can say, which is equal to 1. Now, for example, if you have a number, let's say 389, or I'm going to make it actually bigger. Let's add 5 and 2 to it. So now, if I'm to put these numbers in these boxes, 2 would be here, 5 would be here, 9, 8, and 3. Now let's see what it means. Well, here we have 2 times 10 to 0, or times 1, which makes it to 2. This one is 5 times 10, which is 50. This one is 9 times 100, or 10 to 2, which is 900. This one is 8 times 1,000, or 8,000. Sorry, it should be, 8,000. And this one is 3 times 10,000, which is 30,000. Now, if we add these numbers, we will get 3, 8, 9, 5, 2. And as you see, the number is the same. So that's called the decimal system. Now, what is binary system? Well, binary system also has boxes. But the difference is that now these boxes are, the difference between these boxes is the factor of 2. For example, this box is 2 times bigger than the first box. This one is 2 to 2 times bigger. This box is 2 to 3. This box is 2 to 4, right? And, well, if you have a look, if we go back here and have a look at this number, we will realize that no digit is more than 9, or no digit is more than no digit is 10 because it cannot be 10. So what it means here means that each box of the binary cannot be more than 1. So we can only have 0 or 1, 0 or 1, 0 or 1, right? Now, let's assume that we have this number. I'm just gonna delete this one. Let's assume that we have 1, 0, 1, 1, 0. Now I'm gonna put these numbers in these boxes 0, 1, 1, 0, 1. So let's see what it means. This box, as we know, is 2 to 0, and 2 to 0 means 1. So 0 times 1 is just 0. So the first number is 0. This one is 2. 1 times 2 is 2. Just gonna put this here, 2 is here. And then this box is 2 to 2 times 1, which is 4. This one is 0 times 2 to 3, which is 0. And this one is 16 times 1, which is 16. Now I'm gonna add these numbers, and I'm gonna have 22. So this number means 22. So 22 in decimal is equal to 10110 in binary. Let's see if it's right. So to convert it back to binary, I'm gonna divide the 22 by 2's because simply I want to know how many 2's are embedded in 22, or how many of those boxes will have 1. So 22 divided by 2 will be 11, and the remainder here will be 0. Divided by 2. By the way, if you need any help with long division, I have another video that is explaining the long division, so you can just watch that video. 5 times 2 is 10. We have 1. 5 divided by 2, 2, 4 minus 1, and 2 divided by 2, 1, 2 minus 0. So now I'm gonna 1, 2, 3, 4, 5. Now let's have a look. We have 1, 0, 1, 1, 0, 1, 0, 1, 1, 0. Isn't it right? So you're gonna read it from here, 1, 0, 1, 1, 0. And that's really interesting. And that's just showing you how to convert it back to decimal. Well, that was about decimal and binary. If you need more examples on decimal and binary, I've put some examples in my website. You can find my website in the description box below. Thank you so much.